Ladies and gentlemen, distinguished guests, as you will have heard, I'm unfortunately not able to give this presentation in Hungarian. My Hungarian knowledge is virtually non-existent. I learned today that you do have the same word as I do in Bavarian as a greeting, which is servus, so I will say servus everyone. It's a pleasure to be here. I would like to express my sincere gratitude to the Széchenyi University for extending the invitation to me on the occasion of the ITU World Telecommunication and Information Society Day. We heard in the opening remarks from Ms. Sesi on behalf of the ITU Director Mario Maniewicz that this year is all about digital innovation and sustainable development. These are also exactly the two things I would like to pick up on in my presentation. One is innovation from the view of a satellite operator, and the other one is sustainability. Now, I encourage you all to think about when you last had an interaction with space. Your most recent interaction with space might be more recent than you think. Maybe you used GPS to find your way here. I certainly did. Or maybe you used recently Wi-Fi on an airplane. Or maybe you just simply checked the weather forecast for the weekend. It's clear satellite-enabled applications are a fundamental element already now in our lives, and in the future, they're only going to increase. Services from satellites in non-geostationary orbits, or NGSO as they're also referred to, such as, for example, the low and medium Earth orbits, which we already heard a bit about in Dr. Istvan's presentation, are joining the services offered from geostationary or GSO, enhancing the solutions that we can offer to our customers. Now, as a quick recap, the satellites in the geostationary orbit, they occupy a position above the equator at a precise altitude that results in the satellite appearing to be fixed above the Earth. So it essentially looks as if it's rotating with the Earth. In contrast, NGSO satellites appear to move over time relative to the Earth. Now, addressing the different customer requirements and expectations requires going forward having satellites in a variety of orbits, not anymore just as it used to be in geostationary orbits. Operators are therefore developing multi-orbit strategies in order to address those varieties of customer demands. This is the first area I'm going to discuss. One of the many new and quite exciting technological applications happening across various orbits, and we heard a bit about this already this morning as well, is direct-to-device. Harmonized standards here, such as the Third Generation Partnership Project, or 3GPP, are open standards, interoperable ones, that allow for different architectures and an entirely new ecosystem to be developed. This opportunity then, consequentially, brings service provision in GEO together with new and exciting possibilities in LEO or MEO. But I would be amiss if I didn't also talk about the challenges. All of this is, in a way, under threat by the way that space resources are currently being overconsumed by a few systems with many thousands of satellites in orbit. This is the third area I will cover, sustainability. Here, the approaches of just a few are challenging the effectiveness of rules that were made for a much simpler time, before anyone envisioned many constellations of many thousands of satellites. And we already heard, to an extent, something about that from Ms. Sesi this morning. we have realized that the existing sharing approaches of yesteryear no longer work. However, of course, the space sustainability affects everything and everyone. Managing the use of space to ensure access by all nations, by all regions, Europe of course included, is vital to the stability of the global ecosystem. And it is and will always affect all nations, large and small. It will affect satellite operators such as ourselves. It will affect launch system providers, semiconductors, satellite modules, the entire up and down value chain, including, of course, financing and insuring the satellites that are launched in the variety of the orbits. Ensuring these opportunities for both commercial and sovereign purposes requires a new approach from regulators, one where the spectrum authorizations and the market access processes are actually used to evaluate the risks and rewards presented by a proposal to provide satellite-based services within a nation's territory and to impose conditions to ensure that a nation's needs, such as Hungary's needs, are met and its sovereign interests continue to be preserved. But let me start with the multi-orbit strategies. Satellite operators, like any other business, small or large, have one key goal: servicing the customer in the best way possible. For satellite operators, one of the crucial factors is the platform on which the service is provided. You could, if you want to, think about LEO or GEO as just that, points in the sky from which radio transmitters can operate. They're not necessarily different technologies. Rather, they're using different orbits to provide different benefits and can therefore help meet different service level objectives. We, as Viasat, as Inmarsat was acquired last year by Viasat, we can expect to see a growing blend of multi-orbit strategies to meet all of the needs of the various end users. As Viasat, we embrace a multi-orbit approach to the extent it meets our customers' needs, our customers' objectives, and our customers' goals, because we very thoroughly believe in using the right job for the tool that the customer has hired us to do. Each orbit type, as we've already heard, has its own advantages. For example, GSO orbits allow satellite capacity to be focused where it is needed the most, while NGSO orbits allow lower latency services to be provided where needed. Highly elliptical orbits, for example, such as those used for our Global Express 10 satellites, allow optimized polar coverage for aeronautical, shipping, and other vital needs in those particular areas of the globe. Now, an effective multi-orbit strategy can combine all those different capabilities of the different orbits to respond to customer needs efficiently and effectively. These capabilities can, of course, be mixed and matched in different ways for different customers and applications, which critically reflects the fact that going forward, there really is no one-size-fits-all approach anymore to servicing customers. An example and illustration of the benefits of the multi-orbit strategy is direct-to-device. In the past, we thought of connectivity via satellite. When we thought of connectivity via satellite, we would think of, for example, phones on chips or in very remote locations. However, now, we're at a time, as I mentioned before, where we can rely on a harmonization of standards, which is particularly driven by the third generation partnership project of 3GPP around chipsets and the associated spectrum that they use. And this is essentially allowing an entirely new ecosystem to develop. Conventional mobile phones will soon be able to connect to satellites in a converged manner under the new non-terrestrial networks. This opens very substantial opportunities to deliver new and enhanced services. However, in a world where terms are often unspecified, I would like to be clear. The term device does not only, or need not to be limited to the notion of a handheld mobile phone. A device really can be many things. From devices in your home, more broadly in your house. It can also be connected aircraft, for example, agricultural equipment, or indeed sensors at industrial locations. Indeed, those services, those devices, are becoming increasingly connected with the revolution that we have come to call the Internet of Things. Now, in direct-to-device terminology, you differentiate between narrowband non-terrestrial networks and new radio non-terrestrial networks. Narrowband non-terrestrial networks, such as IoT applications, emergency messaging, asset tracking, very much already exist today. Now, new radio non-terrestrial network applications are, I would say, a few years away in trials now, but I think in the sort of speed with which things move, we can say they might be right around the corner. These are exactly the very types of applications that, for example, the mobile satellite service bands, which are the bands that are currently also designated in the 3GPP standards, have exactly been designated to support. In particular, Inmarsat, but also, of course, now Viasat, look very proudly at the substantial heritage that we have in providing services in the MSS band directly to customers. Those of you who have come across Inmarsat before will know that, of course, the MAR is for maritime within Inmarsat, and exactly is to the point that Inmarsat has for a very long time now been providing safety of life at sea applications with the L-band system that it uses with a number of geostationary satellites. I would like to draw a distinction here to what we heard previously on a number of constellations that are providing direct-to-device connectivity in mobile terrestrial bands. Yes, exactly. MSS bands have always been, will always be designated to exactly that, mobile satellite services, unlike what you have in the mobile terrestrial bands that, of course, are right now predominantly used for the provision of services here on the ground, but there are several companies working to provide services in that particular spectrum, but from satellites. Our heritage does not only include, for example, the long and extensive experience that we have as an L-band operator, but it also includes things, as I mentioned before, such as the Inmarsat satellite phone. We also have, for example, and this is one of the areas that I look after in the firm, the European Aviation Network, which is a service that is tailored to the provision of internet access to airplanes in European airlines. This is, for example, a genuinely European example of enabling connectivity to handheld mobile phones and tablets by satellite while the end user is on a plane. With the harmonized 3GPP standards, Device makers, operators, manufacturers, and others up and down the value chain will all be able to contribute to further develop the direct-to-device ecosystem to expand the opportunities for everyone. This harmonization really is what allows us and D2D services to truly expand the connectivity across multiple large and diverse segments, including telecommunications, government, agriculture, and automotive. The latter of this, of course, being a proud cornerstone of this region, and also with various engineering degrees of this particular educational facility. Expanding this connectivity will benefit consumers, movers, and business users, including those living in or passing through the unserved parts of rural, suburban, or actually even urban environments. As Viasat, we're progressing with several partners across different user groups. We've launched, for example, a partnership with Skylo. We're in discussions with a number of mobile network operators and manufacturers and other solution providers to end up offering direct-to-device to customers. Now, I hope it's clear that there are many exciting opportunities, not just the ones that I mentioned, but also the ones that were mentioned before, on the horizon. This is not necessarily just the case for all of you as consumers or us as operators, but it's also the case for nations, as an ever-increasing number of nations actually have interests in space and want to pursue those interests. As I said in the beginning, the existing rules that govern the use of space no longer work. They were very much developed in an area where we really only were looking at geostationary and maybe a handful of rather small non-geostationary networks. But before I start outlining the overconsumption problem, let me first give you some background. Firstly, the increase in the number of spacecraft. We've already seen this morning, or already heard this morning, about a fraction of the number of spacecraft from, for example, the Starlink constellation. It's important to note that we're in 2024, the number that was given for just that constellation was about 5,300. If you only go back about 6 years, you will find that at that point there was a mere 2,000 satellites in space at that time. If you look ahead, you can see, if you trust the projections, that there might be more than 100,000 satellites in the various orbits by the end of the decade. If we follow what Ms. Sessi told us in terms of what the amount of satellites might be that have been filed for with the ITU, then of course this number could be several times higher than just the 100,000 that I mentioned. Now, all of this, as some of you will know, is coupled with a growth in the orbital debris problem, which results in a growing congestion of the low Earth orbit space, and of course, ultimately, increases the likelihood of collision events that can disable or even destroy satellites, and then subsequently have devastating effects on our satellite communications. You've also heard from the ITU today. If you had others, such as the UN or the European Space Policy Institute, they would very much tell you the same. The orbital resources that we have, in particularly closest to Earth, in low Earth orbit, they are finite. Even with the best management measure, and right now, and you might have sort of heard that this morning as well, there are no management measures to this. A finite resource cannot be turned into an infinite one. Thirdly, the many thousands of satellites, in particular launched by the so-called mega constellations, consume substantially more than their fair share in terms of spectrum and associated orbits. These are, of course, made possible by the fact that few of those are self-financed and vertically integrated companies, meaning that they build the satellites in-house, they can launch them subsequently, and they can, as we've seen this morning as well, also, let's say, stomach the fact that quite a large percentage of the satellites that they launch actually don't necessarily end up working the way they want to. Now, these actions, as I mentioned beforehand, have the potential to not just constrain, but possibly even preclude the ability of others to participate in the space economy up and down the value chain. Now, many regulators, including of course also the US FCC, have recognized that the approach adopted by some of these operators creates significant negative externalities, because the cost of an operator's unsustainable operations aren't borne entirely, or in many cases even mostly, by that operator. Rather, those costs are borne by all who use or benefit from the use of space, which of course includes all of us. Consequently, certain individual operators are incentivized to prioritize their own benefit and their own short-term interests above the long-term interests in the use of space by all, or what is commonly referred to in economic theory as a true tragedy of the commons. This is why new regulation is needed, and we already heard from the representative of the ITU this morning that there need to be steps taken for the entire world to ensure and to be able to maximize the use of, the access to, and the benefits from space. We already heard about the World Radio Communications Conference earlier today. At the World Radio Communications Conference, we've seen a particularly large group of countries call for an equitable access to space by the entire world, by the nations that were present. That nations called for ensuring the continued vitality of national and regional satellite systems, alongside, of course, the ability of countries to be able to develop their own global NGSO systems. And nations demanded more control over who offers services within and to their national territory. Europe, at this very moment, and very soon for the Hungarian presidency, of course, finds itself with a similar opportunity to shape the regulatory outcomes when it comes to preserving space the way we know it. I am certainly optimistic that the Hungarian presidency of the European Council will play a critical role in ensuring the equitable access to space for all European nations and market participants, with strong requirements around market access. In summary, ladies and gentlemen, space provides substantial, exciting future opportunities. Multi-orbit strategies combine the capabilities of different orbits to provide opportunities that can address customer needs efficiently and effectively. Harmonized standards are allowing an entirely new ecosystem to develop under the umbrella of direct-to-device. And most importantly, we need to ensure opportunities for Europe and the world more broadly in space for the foreseeable future, and that requires a different approach to regulation than we have taken to date. Doing so is critical for the benefit of everyone, up and down the value chain, including the entire ITU community, the Hungarian space sector, and each and every one of us as current and future users. Thank you very much.